Okay, let's talk about list comprehensions and generator expressions in Python. So, list comprehension is a way to build a new list by running an expression on each item in an existing iterable object. But I really like to explain this with examples. So, suppose you have this code here. We make an empty list, and then for x in this other list, we want to append to the new list whatever x is multiplied by 2. This is one way to get a list that doubles every item in a different list. And you can see that it works. But this is 4 lines of code to get that result. Python provides us with some syntactic sugar for exactly this situation. Syntactic sugar is when a programming language includes a construct that allows us to be able to do something concisely and clearly. Now, that syntactic sugar in Python is called a list comprehension. We could see an example of it right here. So we're going to make a new list. And this time, we're not going to do it in 4 lines, but rather in 1. So here's how you should read this. For x in this list, return x times 2. It's important to note that we need these brackets around it for it to be proper list comprehension syntax. Our new list now will be the same as the doubled list that we saw above. You can do the same thing for any operation, not just multiplying by 2. Here we can see creating a list where we square every number in the iterable range 3. 0 being 0 squared, 1 being 1 squared, and 4 being 2 squared. Remember that range omits the final number. Right? Okay, so now let's look at a couple of other examples. And we'll do that by comparing the for loop and the list comprehension, both of which you now know, to the map, which is the next one that we're going to learn. So each of the following examples are going to produce the same collection of values. The examples use the same iterable object. Now here's going to be the difference with map. Map applies a function to each item and then returns an iterator, whereas comprehension applies an expression and generates a new list. Let me show you what I mean. So let's use a for loop and list.append first. We have our list, and we'll call it listo again. For x in range 3, let's do listo.append. And what that's going to do, let's print that out, is give us 1, 2, 4. Now, we're going to use map. So what map does, map is a built-in in Python that allows us to pass in a function without a name. In Python, we call that a lambda. That lambda takes in x, and it gives us 2 to the power of x. So that is the first argument to the map, is the lambda, the anonymous function. The second argument to map is the collection that we want it to run that operation on, in this case, range 3. We then assign the result of that to an iterator. And let's take a look. What is our iterator? This time you'll notice that our iterator isn't a list. Instead, it's a map object. And if we want it as a list, we need to convert it into one. Now, let's take a look at the list comprehension that we just saw. The list comprehension produces a new list, not an iterator. We're going to do, for x in range 3, 2 to the power of x. We'll assign it to listo. There you see the list again. So we have 3 different ways of doing this same operation. Now let's talk about getting a little bit more complicated with list comprehensions. That is, let's talk about nested and conditional comprehensions. You can nest comprehensions as deeply as you want. The first for loop is the one that appears the furthest outside of the list comprehension, and subsequent ones are nested inwards. So let's take an example. We'll name our variable listo, and what that's going to do is it's going to take an xy pair for x in a and b, for y in 5 and 17. The clearest way to understand what this is doing might be to print out the result. So here's what's happening. Here we are doing we're going to do for each item in 5 and 17, we're going to create a tuple for each item in A, B with 5 or 17 on the end. So we get A, 5, A, 17, B, 5, B, 17. So, to explain this another way, we are saying the possible x values are A and B. The possible y values are 5 and 17. And for each of those, x and y, make us a tuple that goes x and then y. Now, one of the things you might note about this is that deeply nested list comprehensions can quickly get confusing. So I would recommend against using them for clarity. Now, there is another thing you can do with list comprehensions, which is that you can use conditionals to filter out items. Here, let's make a list of everything from the collection 3, 4, 20, 50 that's greater than 100 by saying, give me x for every x in this collection if x is greater, 10, not 100, greater than 10. That's going to give us 20 and 50 because the check fails for 3 and 4. This is a little bit clearer to read, and this is probably okay to use with list comprehensions in practice. Now let's talk about set and dictionary comprehension. Set comprehension uses a very similar syntax to list to generate the set, but instead of the square brackets, we are using these curly braces. So what we're going to do is get every x in this list for which x is less than 4. Now that's going to be 2, 3, and 3. What do you think the result of this operation is going to be? Instead, we get just 2 and 3. The reason for that being that a set keeps unique values, and since 3 is not unique, only 1 is saved. Dictionary comprehensions use the same literal dictionary syntax, but they require an iterable object to be an iterable containing key value pairs. So here's what we mean by that. We're going to make an iterable that zips up these two things. Let's take a look at it. So we've got a zip here, which is fine. You can see that if we made this a dictionary, we would get keys and values. Great. So now what we're going to do for the dictionary comprehension is in iterable, our dictionary, give us key value for the tuple of keys and values in our dictionary if the key is uppercase. Now it's worth noting here again, a dictionary requires that the keys be unique. So we'll lose a key in this comprehension. Now let's talk a little bit about generator expressions. Generator expressions are similar to list comprehensions, but instead return a generator object that produces results one at a time instead of building a list in its entirety. You'll recall that this is helpful for memory efficiency and sometimes speed, especially speed of being able to access values at the beginning of a computation before those at the end are done. Let's look at an example. Once again, we have a change of syntax here. Instead of using the square braces like a list or the curly braces like a set or dictionary, a generator expression uses the parentheses. So we're going to increment a generator. What we want is some value plus 1 for every value in 1, 2, 3, 4. Let's go ahead and loop through our generator and see what happens. We get 2, 3, 4, 5, but getting the values one by one. Just like other comprehensions, we can use conditionals for generators. So now we can say the exact same thing, provided that the value in the generator is greater than or equal to 2. So that should only run these 3 and not the 1. And you see that it works. Let's talk about generated expressions versus the comprehensions that we've seen. What's the difference between a generator expression and a comprehension? Well, the differences parallel the differences between a generator and a list. Basically, the generator expression can produce results on demand, whereas comprehensions produce the results all at once, and you can't get access to anything until all of them are done. Also, the generator expression takes into consideration program performance with regard to time and memory space when consuming an entire iterable. Generator expressions typically require less memory than the equivalent comprehension, and comprehensions may run faster over the entire iteration of the iterable. Now, there's a reason for that related to how the interpreter works, but we're going to save that for later. Finally, if the entire iterable will not be fully consumed, then using a generator may be a better option. So, if you know that you may not need this entire list computed, a generator might give you just what you need without requiring you to wait for the whole thing to be done.